Through various experiments, it was established that an atom consists of subatomic particles, such as protons, electrons, and neutrons. Now, let us look at the arrangement of these subatomic particles in an atom. Different models were proposed to explain the distribution of subatomic particles in an atom. Of these models, the models proposed by J.J. Thomson and Ernest Rutherford are of great significance, as they paved the way for modern structure of an atom. Let's discuss both these models one by one. J.J. Thomson, in 1898, proposed the atomic model called Thomson's atomic model soon after the discovery of electrons. According to this model, an atom is a sphere of radius 10 to the power minus 10 meter with uniform distribution of mass and positive charge, with negatively charged particles called electrons embedded in it. In this model, the negatively charged particles that are embedded in evenly spread positive charge can be visualized as plums or raisins or seeds that are embedded in a pudding or watermelon. Therefore, this model is also called plum pudding, raisin pudding, or watermelon model. Although this model successfully explained the overall neutrality of the atom, it could not explain the results of the scattering experiment conducted by Ernest Rutherford. Also, it couldn't explain the stability of an atom. That is, how the positively charged particles are shielded from the negatively charged particles without getting neutralized. In order to validate Thomson's atomic model, in 1911, Rutherford and his students, Hans Geiger and Ernest Marsden, conducted an experiment called the gold foil experiment or alpha particle scattering experiment. Before we proceed to alpha particle scattering experiment, let us acquaint ourselves with the term alpha particle. Its source, other particles emitted from the same source, and their few characteristics. We know that certain elements emit radiation on their own, and this phenomenon is called radioactivity. The elements are known as radioactive elements. The alpha rays are emitted by these radioactive elements along with beta and gamma rays. Rutherford found that alpha rays consist of high-energy particles carrying 2 units of positive charge and 4 units of atomic mass. Hence, these particles are dipositive helium nuclei. The beta rays are negatively charged particles similar to electrons. And the gamma rays are high-energy radiations like X-rays. Unlike alpha and beta rays, gamma rays do not contain particles and are neutral in nature. The alpha particles have the least penetrating power among the 3. The penetrating power of beta particles is nearly 100 times, and the penetrating power of gamma rays is 1000 times more than that of the alpha particles. Now let us move on to alpha particle scattering experiment. In this experiment, a stream of high-energy alpha particles from a radioactive source was bombarded on a very thin gold foil. The thin gold foil had a circular fluorescent zinc sulfide screen around it. Whenever alpha particles struck the zinc sulfide screen, a tiny flash of light was produced at that point. If Thomson's model is correct, then all the alpha particles should pass through the gold foil almost undeflected. This is because the entire mass and positive charge is uniformly spread throughout an atom. Through various